Yes, good morning. So in previous session, we observed that how to write the architectural body in the data flow style and also in the structural style. Let us see once again how to write the structural model with some other digital circuit. In previous class, we have seen that the structural model for the half adder. Okay. So what is the information you need to have to write the program or to write the architecture in the structural model? That is internal logic diagram. Okay, so in half adder case we have seen the structural model. Now in this session I would like to discuss for the full adder. Okay, so in full adder case I am going to take this type of logic diagram, including all gates, like the sum output is obtained through two XOR gates, x1 x2, and whereas for carry it is obtained through three 2 input AND gates, one 3 input OR gates. Okay, so everybody knows, I think, this logic diagram, and I have given the names to each and every component as x1 x2 for 2 XOR gates, a1 a2 a3 for 3 AND gates, O1 is for OR gate, and internal signal names I am using 4 internal signal names like S1, S2, S3, S4. Okay, because other wires are, some are at the input side and some are at the output. For these wires there is no name, that's why these are considered as internal wires or internal signals. Separately you have to declare with names S1, S2, S3, S4. Okay, already you know the entity declaration for this full adder with 3 inputs and 2 outputs. Now just I am writing the structural style of architecture here. It starts with the word architecture, then architecture name. Here I am giving the name as str of full adder. Full adder is entity name is. Then the declarative part starts in the architecture body. I said that in the structural style compulsory one declaration is there, that is called component declaration. The number of component declarations equal to the number of different components in the logic diagram. So observe here how many different components are there. 3 different components. One is XOR gate, 2 input XOR gate, and another one is 2 input AND gate, and third one is 3 input OR gate. So 3 component declarations you need to declare in the declarative part of architecture body. And also here another declaration is, as per the logic diagram, internal signals. 4 internal signals you have to declare: S1, S2, S3, S4. Okay, so here 3 component declarations and signal declaration is compulsory. Now let us see how to declare a component. First of all, for the XOR gate, since it is a 2 input XOR gate, therefore the component declaration is like this. Start with the word component followed by component name, then is. After that, port of. So each XOR gate has 2 inputs, right? And I am giving the name. For the one input is X and another input is Y, and one output it has, that is named as Z. Okay, if you assume an XOR gate as a separate component, it has 2 inputs and one output. The 2 inputs are XY. Don't see the names whatever the XOR component the logic diagram has. Okay, those names you can use in the statement, not in the declaration case. Okay, declaration case separate names you have to use. So XY are the inputs, Z is the output for each XOR gate. Okay, with the data type is standard logic. Then end component. So component declare, this is the component declaration for the 2 input XOR gate. Similarly, the component declaration for AND gate is AND gate case. Assume the AND gate is separately a component with 2 inputs XY and 1 output Z. So that the component declaration for AND gate is component AND2 is port of X comma Y colon in standard logic, one output that is Z colon out standard logic, and AND component. So this is the syntax for the component declaration for the 2 input AND gate. Now coming to another component declaration for the OR gate, because it is a 3 input OR gate. So in the port 3 signals has to be declared under as a input mode, and one is the output. Okay, so P, Q are the inputs to the OR gate, 3 input OR gate case, and Z is the output. So like that the component declaration can done for the 3 different components of this full adder. Now another declaration is signal. 4 signals are there, 4 internal signals, S1, S2, S3, S4, but all are declared in the same line by separating comma. So signal S1, S2, S3, S4 colon standard logic. Okay, by default whatever the object declared with the signal, their scope is both in out, that is acts as a input and also output. Okay, then begin, that is architecture begin. So the declarative part is over. All declarations with reference to this logic diagram, all declarations we finished. 3 component declarations and 4 signals declared in the same statement. Okay, so after begin you have to write the concurrent statement. For the structural model, what is the concurrent statement? That is the instantiation statement. Okay, so how many number of instantiation statements you have to write? That is equal to the number of components of the logic circuit, the number of components. So in this case, how many components are there? 1, 2, 3, 4, 5, 6. 6 components we have. So 6 instantiation statements here you have to write. Okay, and what is the syntax for the instantiation statement? It starts with the label name. Okay, let us write the statement for the first XOR gate with the name x1, right? So that x1 colon component name. For this XOR gate, what is the component name in the declaration area? That is XOR2. So XOR2 port map of. Okay, now as per the diagram, what are the inputs for the first XOR gate? A comma B, right? A comma B. And what is the first XOR gate output? S1, right? So A comma B comma S1. As per the declaration, A is treated as input, B is also input, but S1 is the output. Okay, so this type of assignment is ordered association list. Okay, or positional association. Okay, one more model is there, that is the named association. In later classes we can also see that style of association list also, right? Now coming to see the instantiation statement for the another XOR gate with the label name x2. Okay, so start with the label name x2 colon component name is XOR2 port map of what are its inputs as per the diagram. S1 is one input, Cin is the another input. So S1 comma Cin comma what is its output? Sum. So write the sum. So like that you can write the instantiation statements for the XOR gate 1 and XOR gate 2. Similarly for other gates, let us suppose for AND gate A1. A1 is the label name colon component name is AND2. Then as per syntax port map of association list. Association list is as per the diagram. So what are the input signal names for the first AND gate as per this diagram, that is C in A. Okay, C in A. So that A comma C in comma, what is its output? S2. So like that, other AND gate instantiation statement also we have to write. Okay, then for the AND gate, AND gate over OR gate. For the OR gate, the instantiation statement is start with O1 because O1 is the label name, colon. Component name is, for the OR gate it is R3, then port map of, what are its inputs? Observe here, S2, S3, S4. Okay, so place S2 comma S3 comma S4 comma, what is its output? Carry. So end with the semicolon. So remember, every statement must end with the semicolon. Okay, so like that we have written 6 instantiation statements in this case because it includes 6 gates or 6 components. That's why 6 instantiation statements. Then finally end with the architecture name, that is end STR, end architecture name. Okay, so in this way you can develop the program, or you can write the architectural body in the structural style. Okay, so in the structural style, suppose if you want to write the program in the structural style, the information is compulsory logic diagram. Okay, based on the logic diagram, some declarations, component declarations is the minimum, or compulsory declaration is component declaration before the begin. The number of component declarations are equal to number of different components, but after begin the statements are considered as the instantiation statements. Their number is equal to the number of components. Okay, so now I am going to stop this session. In the next session you can see another style of architecture, that is behavior. Okay, thank you.